So we can solve one problem. So here we have I have taken this problem from my Thermo 2 book lecture notes. So we have first system of methanol and methyl acetate. So methanol is 1, methyl acetate is 2. The following question provide a reasonable correlation for the activity coefficient. So we have question is like that. So this means A is equal to 2.771 minus 0.00523. So I told you A is a function of t. So we have ln gamma 1 equal to ax2 square ln gamma 2 ax1 square. So in time questions are given, it's written Kelvin, so kilopascal. So you have to plug in the value in Kelvin. So temperature is given 318. So what you need to do is, the first step I told you, you need to find P1 sat. So P1 sat comes out to be 44.51 kilopascal. P2 sat we have 65.64. Then third step is plug in temperature. So also put in Kelvin. So this will come out to be 1.107. Then what we need to do is, we have first is, then we need to check whether we have azeotrope or not. So remember, we have this question for azeotrope. So these are the steps over there. So we have question alpha 1 2 means component 1 and 2. So one time we have to substitute x10 in question EA P1 sat over P2 sat. We know P1 sat, we know P2 sat, we know A. It comes out to be 2.052. Fourth step. Fifth step, we have to substitute x equal 1. P1 sat over EA P2 sat. So the answer comes out to be 0.224. So you see, one value above 1, one value below 1. So it means the alpha will pass through somewhere when x is equal to y. So it means there will be azeotrope. So we can write down 6 step, the alpha 1 2 x10 is greater than 1, alpha 1 2 x1 equal to 1. So we have azeotrope. Now let's find the azeotrope composition. So find composition and pressure as given. Calculate the azeotrope pressure and azeotrope composition. So in order to do that, last time we drew one question. This is the question that we drove, and in last lecture 1 minus 2 x1 az. So we know A, we know P1 set, we know P2 set. So x1 az comes out to be 0.325. So A is positive. So the diagram will look like, I can finish out this paper. So here is pressure, here is x1 and y1. So your P1 set is 44 and P2, so this is 44. I can say P1 set, and this one is P2 set. Okay. So we have isotope. Let's see, first we need to find the pressure also. Then we got this one, then we can find the gamma. So this is 7th step. So 8th step is we have to find gamma of isotope. So gamma of isotope is same question we have this one, EA x2 square. So this x we have to substitute over here, and it comes out to be 1.657. And then the 9th step is you have to find isotope pressure, and it comes out to be gamma 1 is isotope and P1 set. We know already gamma 1, we know P1 set, because x and y are same, so x is equal to y. So the Rhodes law is x1 gamma 1 P1 set equal to y1 P. X and y are same, so these cancel out. So only gamma 1 P1 set. But this question is only for isotope, so that's why it's written isotope. So it comes out to be 73.76 kilopascal. So we got the composition, we got the pressure. So this pressure is higher than both, so it means your diagram will look like that shape when you plot. So the isotope is at 0.325, so this is 0.1, 0.2, 0.3, so somewhere here. So your graph will look like this shape. So this is your isotope, this is your isotope pressure, this is your isotope composition. Okay, both are same. And this is the bubble line, this is the dew line. Now this is how we can solve the problem. So let's see, we already discussed the bubble point, the dew point. So you know already the Rashford equation. So Rashford equation is summation of Zi 1 minus Ki over 1 plus psi Ki minus 1 equal to 0. So when we have bubble point, then psi will be 0. So if you plug in over here, it will come out to be summation of Zi 1 minus Ki equal to 0. So you can split it, summation of Zi, so equal to, Zi minus Zi Ki equal to 0. So if you split them, so it will be summation of zi will be equal to summation of zi ki. So summation of zi equal to 1, so it means zi ki equal to 1. So this is the another condition for bubble point. So similarly for dew point, psi will be equal to 1. So same plug in value over here, and if you simplify, then your answer comes out to be zi over ki equal to 1. So ki you can find either by chart or the figure 2.4, 2.5, or you can use the in time the Rhodes law, P1 sat over P, or gamma 1 P1 sat over P. So whatever you like. So this is, I forget when I was talking about rice for rice, so I can write over here. Okay, so we are already familiar with this diagram. So mainly we have to use this diagram in order to solve the problem. This diagram is also called Cape-Thiele diagram. So x1 and y1. So this diagram is only based on the more volatiles. X1 is more volatile, like in this example we solved. The first one is methanol is more volatile than methyl acetate. So in hydrocarbon usually we see their molecular weight is heavy or low. So also the bonding is matter, like bonding, the strong molecular interaction, they are of course less volatile, like water is less volatile. It has low molecular weight but strong molecular interaction, so it's less volatile. Anyway, so this is the Cape-Thiele diagram, and I told you this is the equilibrium curve. And this is the x is equal to y line, 45-degree line. Okay, or alpha is equal to 1 line. So this equilibrium curve we can draw by y is equal to alpha x 1 plus alpha minus 1 into x. So this is easy. Let's see, what we need to do is, so there is one thing, this is the last topic of chapter 4. There are other things in chapter 4 as well related to chapter 8, but once we discuss chapter 8, that one is entirely different. So because we are going to start chapter 7 after this, so this is the, you can say, the base of chapter 7. So you must have to draw the line, xy line on the graph paper. You must have to draw the equilibrium curve. Then you can able to solve the problem. So in fact, what happened is, like this is the distillation column, typical distillation column. Okay. Typical distillation column. So this is a condenser over here, and we have reflux, whatever, so I will not go in detail. Okay, so similarly here we have so this is a typical distillation column, and we are entering the feed over here. So this is the feed. So this is the feed point, and we can say we substitute here quality. Quality means Q means the quality of the feed type. what kind of feed is this? It's either a bubble point feed, the feed that you are injecting in the distillation column, either is at superheated. There are five, already five categories: the superheated, saturated vapor, two-phase, then subcooled, then saturated liquid, then subcooled. So there are five categories for Q. Quality of the feed. So one is saturated liquid, saturated vapor, bubble, dew, VLE, two-phase, subcooled, liquid, and superheated vapor. So this is about the Q. So what type of feed you are injecting? So this feed and the above section above the feed is called, in distillation column we call it rectifying section. And below the feed is called stripping section. But we will discuss in detail in chapter 7. But we are about to start chapter 7 because the first thing is how to get this Q. So the Q is given in chapter 4. So they have reported and the derivation in chapter 4. So let's dive. So this Q is in the middle. So it means if this is the line, this part is rectifying, this part is stripping, and middle part is feed. Okay. So before drawing, before go for in detail, we will see how this diagram look like. So this is very important diagram, x1 and y1. So this, I told you, the quality will be in the middle. It depends on, let's say you have 50% of methanol in water. So methanol is more volatile. So based on methanol, 50% or 60%, the 50% is here. So 60%, it means your Q will be start from here. We can call XF anyway, the feed composition, 60%. So feed composition of more volatile. So if we draw a vertical line, so this is called bubble line. Mean the bubble is at feed point, the feed is at bubble point. Or we can call saturated liquid. Or the Q value is equal to 1. Or the psi value equal to 0. Q is equal to 1 minus psi. Or Q is equal to 1 minus V over F. So similarly you can go this way, horizontal line, we say psi is equal to 1, Q is equal to 0, and we call this one as dew point. It means the feed that you enter in the distillation column is at its dew point. Or saturated vapor. In between, from here to here, we have VLE, two phase. The feed that you are entering is already a two phase, and here the Q or psi value from 0 to 1. So psi value 0, or Q value from 0 to 1. So it means two phase. So the psi value must be between 0 to 1. So here the psi value is 0, here the psi value will be 1, or we can focus on Q. Q is 1, Q is 0. So above that bubble line, saturated liquid, so we have subcooled liquid. It means Q is greater than 1, or psi is less than 0, but we will not talk about psi over there, basically. And similarly we have over here Q is less than 0, or psi is greater than 1. This is called superheated vapor. So the 5 category, you know already this one diagram. Oh sorry, X1, Y1 and P. So this is subcooled liquid, saturated liquid, saturated vapor, superheated vapor, two phase. Same diagram. Okay, so this will give you the Q value or Q equation where it will be. So we basically in cave theory we need to draw these lines, but for Q line we have only one line. For stripping we also have one line. For rectifying we also have one line. So we need to combine all these lines. So we'll see in chapter 11 or chapter 7 what I mean over there. Okay, so let's drive how we can drive this Q line, because we need to draw this line. So in order to draw this line, if it is given the feed in a problem, the feed is at bubble point, you just need to draw vertical line. But if it is given you need to draw horizontal, the Q is 0, you just need to draw horizontal line. But for the rest you have to calculate. So we know already F is equal to V plus L from flash, and we already know Z1 Vy1 plus Lx1. So we eliminate L. So we eliminate L, Vy1 plus F minus Vx1. So we can take this V on this side. So F Z1 minus so what we can do is we can divide by V on both sides. So this will be F over V Z1, and this will be, so what we can do is we can swap so they make it positive. So plus 1 over V minus F x1. So we can say V over F over V Z1 plus V minus F over V x1. Now what we can do is we can divide throughout the equation by F. So we can write down y1 is equal to z1 over f over v, can take it down, plus v over f minus f over f over v over f x1. So you know already v over f is equal to psi. So what we can do is we can eliminate, we can write down in terms of psi so this is equation in terms of psi. So this is we call anyway, so the slope of the line, q line. So this is the slope of q line, and this one is intercept. So we need, in order to draw a line, we need a slope and a point. So we'll see how we can do that. So that one is composition. So if you know psi value, you can get the slope, you know the point, so you can easily. So we'll see in chapter 7 how we can draw that. So we know already psi is equal to 1 minus q. So we can plug in over here. So we can write down into another form, in q form, z1 over 1 minus q plus 1 minus q minus 1 over 1 minus q. So cancel out. So what we can do is so we can have the final variant. We can this minus, what we can do, we flip this one. So it will be q over q minus 1 x1 plus z1 over 1 minus q. But if you want same q minus 1, then we can do q over q minus 1 x1 minus z1 over q minus 1. So this is the actual question given in chapter 7. So we have to use in terms of q, and this one in terms of psi. So whatever you like, we can have them. So this is all about the q line. So we have, again, this is the q slope of q line, and this is the intercept. So that's all for chapter 4. So we will discuss in chapter 7 the other lines, like so we discussed already chapter this one q line. So we'll, and chapter 7 will start with the rectifying line and slipping line. But before than that, we need to see some theory of chapter 7, what is distillation, and then we can talk about distillation, McCabe-Thiele method, and then Ponton-Severin method. But keep in mind, in distillation always we talk about the more volatile component, the more volatile. So if it is the more volatile, if in hydrocarbons like methane is more volatile than ethane. So we'll talk about everything. We talk about methane, the x1, y1. The 99% we discuss about methane. Only 1% we talk about ethane, because we need to find P2 set for that if we need. In graph, if you use graph, again this graph is also based on the more volatile. That's why I'm writing x1 y1. We are not writing x2 y2, just based on x1 y1. This equation is also based on x1 y1. So alpha value is given. If this curve is smooth, it means we have constant alpha. If the curve is not smooth, you can have different kind of curves. Maybe you can have like this shape also, like this shape. Very frequent is methanol water system behaving like this shape. So sometimes also I showed you so many diagrams, sometimes also like this shape. So many shapes will be there, and you need to solve the problem for that. That's all. So let's see chapter 7.